Throughout the history of our planet, cosmic dust from interplanetary space has continuously fallen to its surface. It is found in the depths of the oceans, in the glaciers and snows of the Arctic and Antarctic, in the snow cover of mountain peaks, and in the thickness of terrestrial rocks. According to various estimates, the Earth's surface is abundantly gaining weight, as from 10,000 to 1 billion tons of cosmic dust fall per year. How is cosmic dust different from that on our video recorders? Benefit or irreparable harm? Who or what is the beginning of this dust? Cosmic dust is particles of solid matter in size from 1 billion to hundredths of a millimeter in outer space. Dust matter is one of the most important components of the universe. It is contained in the interstellar, interplanetary, and near-Earth space of the Earth's atmosphere, descending to the surface of our planet, representing a means of material exchange with space. Interstellar dust surprisingly directly plays a huge role, both in astronomical processes and in the evolution of all life on Earth. But how is the dust? Is it good? In space, despite such a small concentration, particles are a source of organic molecules in interstellar space. The nuclei of dust grains are formed in the depths of stars. Then the forces of the energy emitted by the luminary are pushed outward, slowed down, and cooled, can be explained in a simpler way. The atoms colliding with them stick to the dust grains, causing their growth. As a result, the nuclei are overgrown with various elements encountered on their way, forming a kind of film. Next, ultraviolet radiation performs its task, under the influence of which the disintegration of molecules occurs, photolysis on the surface of dust, as a result of which new and more complex molecules are formed. Throughout its life cycle, colossal explosions mark the chemical elements that form the basis of all life. In one way or another, we are all made up of the same atoms and molecules that were born in their depths many millions of years ago. Recently, so-called fullerenes have been discovered in interstellar space. These are amazing compounds in which carbon atoms form complex structures in the form of closed polyhedra, made up of regular 5 and hexagons. Doctors and biologists use them to deliver some drugs inside a living cell, since fullerene easily absorbs various substances, drugs, and vitamins. It is believed that in the interstellar medium, the germs of life can be preserved inside the molecules of fullerene. The photographs show traces of bacteria found in meteorites by scientists from the Paleontological Institute of the Russian Academy of Sciences under the leadership of Rozanov. Their age is about 4.5 billion years, and the age of their traces in meteorite rocks is even greater. It follows that fossilized remains existed even before the formation of the Earth. The famous British astrophysicist Fred Hoyle and his collaborators put forward a hypothesis according to which a significant part of interstellar dust grains is represented by single-celled organisms, bacteria, or phytoplankton. With regard to the possibility of survival in the interstellar media, it should be borne in mind that single-celled organisms, especially spores, are quite resistant to cosmic rays. This is even more true of viruses. In addition, such organic dust particles will be overgrown with ice shells, which play the role of a protective shield, protected from radiation that can damage it. Perhaps the cosmos is not as dead as it seems at first glance. Countless molecules, or even microorganisms, all this interstellar dust turns out to be in the composition of future planets, comets, asteroids, and it is likely that this can serve as material for the emergence of life on planets, including you and me. Maybe in hundreds of years, these single-celled organisms will learn to talk and tell British scientists what really happened. Do not forget to put huge likes and share this video with your friends. And if you liked our work, then subscribe to the channel.